So good afternoon. Thank you for coming. This afternoon, I plan to split it into two 90-minute seminars, sessions, just to give us some break. But I think we are not going to fit in one 90-minute section because it's just too much stuff, and the spin-up discussions are going to be probably large. So yeah, I'm planning to be here till like 5. If you want to stick with me. If don't, it's going to be recorded, so you are going to be able to probably replay it, as well as some transcript is probably running using Gemini. So maybe even some text notes are going to exist. The stuff that I'm going to be talking about is, I would say, the information in between the lines of the official documentation, plus our own documentation, plus the code. I'm going to be talking about the stuff that you cannot easily get from the available sources, because there is a lot of information specifically about our dead ends that we reached while refactoring everything to ROS2. And I want you to avoid these dead ends to actually be productive. It wouldn't be very productive if every one of you needed to go through all the learning curve yourself, because you would probably hit the same problems and dead ends as us. Many of these problems have been either fixed directly or indirectly, worked around, or we have built processes or tools to get around these. So I'm going to be partially presenting the problems so you know about them and you don't accidentally get into these. And I'm also going to be presenting the solutions, which, if you use them in the first place, are going to totally avoid the problems. I'm going to try to describe the new concepts in ROS2 as best as I can, or at least to give you the notion about these concepts, such that then you can learn yourself in depth how these stuff work. I'm no expert, please. Despite the work in the past year plus, I think I have barely scratched the surface of everything that the ROS2 can do and how it works. I have went wide, but I have rarely went deep into the problematics. There are people who know much more about the particular concepts, specifically Matouš, who has built most of the MRS lib wrappers around the C++ API. There are other people who know much more. David Tomáš, Martin's student, who is helping me right now with some of the build stuff and C++. If you have questions about the deep C++ stuff, David Tomáš or Matouš Vrba definitely will know more. There are other people who know more than me. Philip is my sort of right hand. If you have any generic questions about whatever comes in the future, I would say first post it to Teams, to some generic chat like ROS2 channel or software channel. If you have specific question to me, I would say first ask it to Philip. Philip, raise your hand, please. Yeah. Thank you, Philip, for this huge sacrifice. But Philip would probably pre-filter these questions, answer the stuff that he can answer on his own, and if it's getting into the territory that only I can answer, he will then forward the question to me. As the time goes in the future, I'm gonna be expecting our second baby, so I'm gonna be less and less at hand with helping you. I would love to help every one of you, but if every one of you just ask 10 questions per month, I'm not gonna be doing anything else. So my primary defense against this is this seminar. That should prepare you for most of the stuff. My secondary line of defense is the general chat and Philip. And after that, if there is nothing else you can do, ask myself. The people who already know about ROS2 are obviously Matouš, Philip, the people from the Tom's Lab at the upper floor, so David Čapek, Michal Werner, and am I missing anyone else in the core? Yeah, these are probably the ones that know stuff. So yeah, respect that we are only few people who have used ROS2 in a productive way using the MRS system. So that's the introduction. I have a list of what I intend to talk about. The list is quite long, and these are just the bullet points. I haven't prepared any specific presentation that would be super counterproductive. So I'm just gonna wander through the problematics. Feel free to stop me. Feel free to ask questions if something comes to your mind. I'm gonna be going on the surface a lot. I'm gonna go in depth if I think it's important, but if you think it's important to go in depth, don't be afraid to ask. This can totally turn into a semi-seminar, semi-discussion. So let's get to it. Final check, we are recording. Yes, hopefully the people online can hear us, hopefully. So let's get to it. So first things first, when you want to work with ROS2, you need to either have a native installation or some sort of containerized development setup. I'm not going to dive into the containerized development setups. People nowadays use VS Code with some dev containers, or you can use Uptainer if you want. I'm just going to stick to the native installation, which is what I've been using in the past 12 months. It works. You can totally install Ubuntu 24.04, and on top of that, you can natively install ROS2 version Jazzy. We need to run ROS2 Jazzy because still the particular ROS2 release is tied to the particular Ubuntu release. This hasn't changed. So we are currently stuck with LTS ROS2 Jazzy. And we are going to be stuck with this for maybe another year. Definitely this year. I have no intentions in upgrading before we even start using it fully. Definitely, there are going to be some improvements in the future versions, but right now, I think we are good to go with Jazzy. So the first thing you want to do is you want to dual boot another version of Ubuntu, or you can completely move from 20.04 to 24.04. This is totally doable, even necessary with some of the new laptops and devices. If you are using my own Linux setup, you can totally use the new version on a branch 24.04, which does most of the stuff that you are used to from the old system. I haven't yet refactored some of the niche stuff. That's probably I was the only user of, but like out of the box, the Linux setup should work with NeoVim, code completion, Tmax, Ranger, all of these basic stuff. On a branch, ROS2. By the way, this is a common thing on most of the repositories that we have. Search for a branch ROS2 if you really want to use with or run the latest stuff. I have not yet migrated the branches into the master. I have not yet switched the default branches in the repositories. So by default, everything is still master, which is ROS1. Anything ROS2 specific resides in the ROS2 branch in all of the repositories that actually have differences. So it's gonna commonly happen that you are gonna go into a repo and you forget to switch, and then you are gonna be running and cloning and compiling the wrong stuff. Luckily, it doesn't create any long-term problem. You can always switch to the right branch.
Sorry, when are you planning to switch to ROS2 as the main branch or main?
I haven't yet thought about the actual ramifications, so I don't know. We can discuss this. I would do it now, personally, but I don't know if it breaks anything significant for F4F customers or our partners. I don't know. So I haven't touched this hot piece of metal yet. But personally, I would totally ditch ROS1 immediately, because to me, it's 1 year, 1.5 years old, that thing.
So after the camp?
That would be nice. That would be nice. After the camp, after all of the people will sort of confirm and test that it sort of works, that would be a nice thing, switching the defaults. Yeah. Yeah. So right now, if you go on our GitHub entry point, which you probably all are familiar with, if you switch to the ROS2 branch, or down here in the README, you are going to find the section about ROS2, which points you to the right README in the ROS2 branch. You are going to find a new entry point to the MRSUV system for ROS2. In here, there are the familiar installation instructions for how to install a ROS in the first place and how to install the MRS UAV system. This mechanism hasn't changed, so we install a ROS through the official way from the PPAs of the ROS. And then we add our own custom PPA that is built every day on our servers. And from that PPA, we install the MRS UAV system full package, which pulls most of the stuff with it. And then you have your own native installation. This is, I would say, one-to-one copy of how the installation works with ROS1. Luckily for us, ROS maintained the dependency management system, or the dependency management system called ROSDEP is the same on ROS1 as it is on ROS2. So that hasn't changed. So the usual ROSDEP update command that you need to run to actually have a fresh list of translation from ROS package name to the up sort of package name, that's stayed the same. And the way how we actually fabricate and create the PPAs, it's very same. So the installation procedure is the same. If you go through it, you should end up with native installation where you can, out of the box, start simulating. So here, the command which does cd into our custom multi-rotor simulator into one of the TMAC sessions, it should allow you to start the simulation out of the box. This will start RBase and the MR system, and you should see the same things as in ROS1, luckily. By the way, here is the first little difference that you see from ROS1. In ROS1, this command would be actually ROS-CD into the package. But in ROS2, there is no, like, I would say, official ROS-CD. There is some community implementation which you can install somehow, but we don't have it, or I don't have it. So anytime you are gonna see this, it's not from laziness, it's because you cannot just ROS-CD into a MRS multi-rotor simulator package. But wait for later, we actually have our own shell additions that add ROS-CD into our toolpath. But a generic user without our additions will need to do this. So the installation should go quite easily. It's still the same. The packages reside in the same location in /opt/ROS, so that shouldn't be any different. So that's installation. With the install version, you can obviously simulate. So let me try. If I just put myself in the shoes of a fresh installed system, and obviously you need to then source the right file from opt ROS Jazzy. Jazzy is our version setup.zsh. I should be able to do exactly what the manual says with this and calling the start script. There's always a chance that my computer is in some sort of state, so it might not work, but to most of you, it actually should kind of work, hopefully. Yeah, I bet I'm in a semi-state of all the packages, so I'm not gonna actually show you how it works right now, but yeah, okay, good, awesome. So we're gonna see RBase, you're gonna see architecture configure, and the usual TMAX stuff. So yeah, the drone should take off in a minute, and I have some things broken in my installation. So yeah, disregard that. I'm gonna come back later if you're looking better in showcase. So after you install the system, you would probably want to start developing and compiling and doing stuff that you are used to. This is where the first differences come in. If you remember, we used to have MRS UAV development repository, which only some of you needed to use, or you didn't even need to use it, but it gives you some nice aliases to the commands like catkin build in ROS1. We have this repo as well for ROS2, and I would say it's even more important for ROS2 than it was for ROS1, because it fixes some of the important idiosyncrasies of the terminal user interface and the native command, which are, in my opinion, very rudimentary. So from ROS1 to ROS2, we are undergoing big regression in user friendliness in the terminal sort of utilities. So please, if you are developing natively, clone MRS UAV development, branch ROS2, and source our shell additions. Here is the code snippet for it. It's nothing spectacular. You just source the shell additions as H file. And this fixes some of the important stuff that are not working out of the box. The first important thing is code completion in Bash or Z shell. Doesn't work out of the box for the ROS2 command, for the colcon command, which is the new Catkin. So inside the shell additions, we are doing stuff that makes it work. We are also implementing our own ROS-CD. I love ROS-CD. I usually move through the packages quite a lot. And being able to just call ROS-CD into a package is a big time saver. So I've implemented my own ROS-CD, which kind of works, basically, quite identically to the original one. And it's in the shell additions. The shell additions so you might, when working with Python packages, and that is workspace caching. Observing, I mean, if it's a problem still right now, that was definitely a problem a year ago, a half year ago. If your workspace is full of packages and some Python packages, the actual thing of the workspace can take a really long time. I mean, 3 seconds, maybe 4 seconds, which if you tend to have ROS2 sourced or the workspace every terminal like I do, it's a pretty big, like, because every of a terminal would suddenly take 4 seconds sourcing the stuff. So I have implemented a way how the actual act of sourcing does. The source recursively crawls through the work and stuff and creates some variables and dynamic process. And this dynamic process has an outcome of aliases and variables, and this outcome is backed up. So what I'm doing is I'm basically taking the sourcing process of a workspace one level further from the actual of the file, and I'm producing a cache. That is then when it exists, which makes the process much faster. So this is kind of important thing, but you don't have to use it if you don't want to, but I am quite happy with it. And one last thing which is kind of important is prevention of unwanted linkages between the workspaces. If you have multiple workspaces in ROS1, typically explicitly state how they are linked together by something like catkin extend, catkin config extend, if I'm not mistaken. This was nice in ROS2. We had an explicit control over how they are linked. In ROS2, there is no explicit control. The linkage is created automatically, and it can be created automatically on accident. If you have two workspaces, one is sourced, you are compiling another one, suddenly magically another one workspace is going to be linking into the one that was sourced, and this link cannot be undone unless you want to completely clean the workspace, which can be sometimes half an hour of compilation time because you accidentally compiled workspace B while having workspace, even though they don't necessarily need to communicate. So I implemented a quick mechanism that doesn't allow you to compile a workspace is sourced, which prevents this. Which brings me into one last point, which is colcon. We don't have Catkin anymore, that tool that managed workspaces in ROS1 that was, in my opinion, very elegant and beautiful. We have Colcon, which
Sounds like colon.
sounds like colon and behaves exactly like colon. Yeah.
It smells like that.
And smells like it too. It's worse in every aspect. It has bad habits. Bad habit number one, if you use the native Colcon and call Colcon build, it will just create a workspace where you are, even though you are in a subdirectory of another workspace, which is incredible. Like, I don't know how people can use it. So in the shell additions, we have our own alias around building in the root directory, even though we are calling it in a subdirectory. And it implements something like Colcon init. There is no Colcon init. Colcon init is actually Colcon build, but I sort of like the distinction between initializing and building, so I've like rebuilt the original Catkin init basically. And there are probably more stuff that I already forgotten. So I would say just easier. I have not actually changed many functionalities. I have basically fixed problems. The only groundbreaking change and breaking change for you might be the workspace caching, which sometimes needs special treatment if you want to do stuff. And I'm going to talk about this. So Colcon is the first different thing. If you want to learn how to work with Colcon, we have a manual for that already, quite a good one, on our FEE-CTU-MRS wiki. This is the first time the wiki has currently two versions, 1.5 version, which is the old ROS1 system, 2.0 version, which is the new ROS2 system. Many of these pages have been updated to ROS2, but it might happen that the page will still contain obsolete info. That's because no one had time to fix it. If you find such a page and you actually want the information from it, please update it yourself after you learn how the stuff actually works. I don't have time to update all the pages. All the time, the documentation was sort of crowdsourced, so please contribute by fixing the stuff that is incomplete. Plenty of pages there are some incomplete. Anyway, make sure you are on the 2.0 version. If you are searching, I don't know, Colcon, sure when you are clicking the ones with the 2.0 version, it's still searching through the 1.0 version as well. So always make sure you have a manual here for Colcon. So please go through it when you have the time. What's important to know with Colcon is, number one, the original mechanism of profiles or build profiles that Catkin integrated directly into the workspace, this mechanism is gone. It used to be such that you could specify for each workspace what build profiles you want to use and how they actually interact with the package, what they export. And you could easily switch between them by Catkin profile set. I think this was completely removed, and it was replaced with a new feature called mixins. To my understanding, this is basically an external software or product that was somehow linked to Colcon. If it's not external, I don't understand why you need to install it separately and why it basically lives in its own world. Anyway, discussions aside, if you install the tool called Colcon Mixin, this will allow you to specify build profiles in some external files. They typically sit in home config /mixin or home ROS. I forgot already. Yeah, it's some. No, sorry, I forgot. I don't interact with this manually that much. The thing is, the profiles are specified. You can use off-the-shelf profiles, and you can use custom profiles. We have a repository which defines our own profiles sitting in C2MRS/Colcon Mixin, which defines our own testing profiles and stuff like that. You basically install this once, and then you can create a file in the root directory of a workspace called colcon defaults. By the way, I'm going to do this, colcon defaults. And in this file, you can specify which profiles you want to mix into the build. Very clever. So if you want to build with release or rel with dep info, you have to actually have this file in the workspace that specifies that you want to add or mix in these build profiles. I typically build with rel with dep info if I'm not debugging anything specific. And I like to add compile commands mixin, which make sure the JSON with the build commands is exported such that my NeoVim can actually tap into that and it will know how the stuff is compiled such that it can give me code completion. So I would say this should be your sort of default colcon defaults YML, which colcon will open parse during every build. By the way, this YML file is basically one-to-one reflection of all the arguments you can give to colcon. So if you find yourself giving colcon some arguments for whatever reason, and you do that repeatedly, you can just shove them into this YML file, and it will give the arguments automatically.
Not all arguments are.
Not all? I've so far
most of them.
Okay, I've yet not found any argument that would not be passed, but there might be a. So in my case, if I workspaces, you typically find a colcon default file in the workspace that does things. And in my case, I typically add mixins. Since I have very little RAM in my laptop, I typically need to eliminate parallel build of the packages. So I build sequentially. You can specify that here as well. And I typically specify that my install folder in the workspace is going to be symling. So most of the files are going to be source folder and are going to be copied. This is important to the Python guys that need installed. It's better to link them rather than to copy them. Which brings me to another difference of colcon versus Catkin. In ROS1, we used to have the devel folder, the build folder, and the source folder. Most of you share the devel. And whenever you build your stuff, basically the runtime libraries and binaries were placed into the devel folder, and when you did ROS launch, it would load the stuff from the devel. And then there was a special case if you produced your dep packages. The dep packages would actually use an install folder, which you would normally use during development, and you would have to correctly specify the installation sort of procedure in the CMake list to move the right stuff into the install such that it's then part of the dep package. That was ROS1. In ROS2, the devel folder part is missing completely. It was skipped. There's no development stage, basically, and there's only the install. So whatever you want to compile, if you want to actually run it, you have to correctly specify the install section in your CMake list such that binaries, launch files, config files, the libraries are all part of the install folder such that they can be actually started. So this adds more pressure to you as developers. You have to have the CMake lists correct, start to bottom. In ROS1, you could basically completely omit the installation section if you were just developing or running the stuff from a workspace. Here you have to have it correct. Bonus, if you have it correct, making a dep package out of your package is then basically guaranteed making it's going to work. If it worked in your workspace, that means that the installation procedure happened correctly, then the dep package will work just as the development process. So in my eyes, it's actually an improvement. It's less ambiguous, and it forces the developers to do their stuff right in the beginning. So no devel, and whenever we are sourcing workspace, we are actually sourcing install/setup bash shell and stuff like that. Yeah, so colcon is building the workspace. There is no devel. You have the install folder, and the colcon defaults can help you configure how the workspace is behaving. This is all in the manual, I think. Yeah, how to build. Yeah, if you want to have colored output set up, you have to install some other stuff. I honestly don't know if I ever did it. I might be just living with the uncolored output of Colcon build. I don't know. I don't care that much. I have bigger problems in front of me than having colors. But there is a manual of how to do that, and there are some troubleshooting sections. So please use this to get started with Colcon. There was one last point I wanted to tell you, but I now forgot. Yeah. What was guaranteed in ROS1 is if you have multiple workspaces, so basically you have the opt-ROS space, which can be extended by workspace number 1, which can be extended by workspace number 2. In ROS1, this extension mechanism basically guaranteed that if you are building something which is already provided by the underlayer, the system is gonna use the topmost layer. So if I'm gonna do a change in MRS slave, I'm gonna build it here, use it in here. The packages from here are gonna link against the MRS slave here and not installed in the system. This was sort of given in ROS1. In ROS2, this is not guaranteed. These overlays are not always respected. If I'm not wrong, I might be wrong, but I think that you can quite easily fix it by adding another section into the Colcon default file, which is called allow overriding, where you basically specify what packages you are building in the workspace that should be used over the packages that are in the underlay. I have not yet had a problem with this. The Colcon build process will even spit an error if you don't do this, and it will suggest that you should do this. I think it's the solution to the problem. I'm not sure. Some C++ guru might tell me that there is an actual some problem with this, but do this. Use allow overriding to actually specify what you are building in a workspace that you want to be used in a priority way over the underlay. I'm not sure why this isn't automatic. Basically, all the packages that I'm building here, I probably want to use them over the ones in the underlay. But you have to specify it like explicitly. Fine. So this is probably one last point about Colcon. So otherwise, like if you want to build stuff, my process typically goes around making the folder for the workspace. So workspace demo, I cd into the folder, I take the source, then I clone something in here. So examples, for example, CTU MRS core examples, -- branch ROS2. Don't forget about that, because if you don't that, and if you build ROS1 package in a ROS workspace, it's gonna scream that Catkin isn't installed or something like that, because we don't have Catkin anymore. So I'm gonna build this. So I clone this. Now, when I'm creating a new workspace, you always want to be sure you are not sourcing any other workspace. So in my case, I'm going to check my ZHRC. If it's all clean, looks good. So I'm going to cd. By the way, as a check, you could first check if you have a ROS2 command. That means you sourced opt-ROS in some way. And then with my shell additions, you can do ROS-CD. If you do ROS-CD, and you are not sourcing any workspace, it's going to end up in opt-ROS Jazzy share. So I don't have any other workspace active. So now I should be able just to do cd workspace demo called init. And the first init is actually built. Yeah, Catkin init used to do just the initialization, no building. With Colcon init is because there is no init.
Yeah. Why do I have this? Because I don't allow running colcon build in a folder that is not a workspace or a child of a workspace. So colcon build, in my case, cannot serve for creating a workspace, because that would violate the rule of don't create workspace whenever you are calling colcon build. So that's the reason why I created colcon init, because I don't like automation that much to want workspaces in all my subfolders. Yeah, so workspace is built. You should totally see the normal build install stuff. So I did a rookie mistake. I totally forgot to create the colcon default file. So my build is now happening without any specific build profile, so without optimizations. So if you do this mistake, the packages will not run very effectively because they are not optimized, unless somebody actually hard-coded -O2 in the CMake list, which is not a good thing to do. So in my case, I would probably need to do colcon clean, which also doesn't exist by default, but I have implemented it to actually remove the install and the logs folder. So right now I should actually create the colcon default. So I'm gonna borrow it from here, pass it here. Did I copy it? Please work. Yeah. So stuff like that should be enough for the start. Sadly, I think there is no real verification that the colcon default is used. If you make a typo in the file, you are gonna sort of never know that it is not used. So what I typically do, I check the. So since I built everything with compile commands, after the build, you should find the compile command file in the build folder. So that's my sort of check that actually have the colcon defaults without a typo. So if I go into the build, I'm gonna find compile command file, which is used then for the CLang to tell me what I belong. Yeah.
But this can be extended into the UAV deployment.
It could actually force users to create this file. It would be probably the best. Just things warning. Okay. To use colcon defaults. I don't remember how to do this. Okay, awesome. Yeah, so we could force users, or touch whenever it's missing.
We just want a user that was built at the beginning that are missing.
Yeah, awesome. Yeah, so that's the process. Quite important process. So after the workspace is built, you need to source it. So I'm gonna right now tell you how the caching process works with the MRS UAV deployment. I think it's beneficial to use it anyway, because it then does the check for the building of a wrong workspace that is not sourced, which can save you a lot of half an hours of build time, because unlinking a workspace is not possible in a nice way. So if you want to use the caching, you only have to do one thing, two things, three things. Okay. Thing number one is you have to source the shell additions. So yeah, source the shell additions. And the shell additions are sort of clever. If you don't do anything else, they are gonna source ROS Jazzy setup ZH or bash for you. So in my workspace, you are not gonna find any explicit sourcing of ROS, because I'm doing that in the shell additions for you. If you don't want to source just the installed ROS and you want to source your workspace, you have to export variable ROS workspace with the path to the root of the workspace. If you do this before the shell additions are sourced, so this has to happen above the sourcing of shell additions, the shell additions will read the variable and they will first source the workspace and then they do the cache for the space. So if for example, I have some workspace here. I export ROS workspace and open new terminal.
Why? Sorry? Yeah, working on a lot of stuff. I think. Okay. Now telling the big picture is difficult. It's interesting, yeah. So I'm gonna start from the end. The workspace cache, which is typically used and you don't code it, sits in temp. So if I check my temp, there's gonna be a file that is called ROS resource output.sh. I haven't found a better name in. And this is what is actually sourced whenever the cache exists. This is the cache. And the cache looks like some lot of exports and stuff. This is the produce of the caching. It's like 150 lines. The actual pre-cached version would be over 1,000 lines of shit that's even more complex. So, rule number one, if you have a problem, just delete the cache and let it create again. The problems can be of different sorts. Problem number one, the cache is old, meaning you have added a new package into the workspace, you have compiled the workspace, and you don't see the package. That's because the cache is old and it doesn't contain the knowledge about the package existing. Rule number two, something's broken, whatever, remove the cache. If I remove the cache, so I'm just gonna do rm ROS resource output.sh. I'm gonna close the terminal, open new terminal. The terminal will spit out something like Qualcomm workspace, workspace DIO, post resourced. This means that the workspace was sourced for the first time, the cache was created, out into the temp, and right now, if I open new terminal, you don't see any output. That's because everything is happy. The workspace is actually sourced. If I do ROS CD, I'm gonna end up in the workspace. I should be able to do everything like I'm used to. The only problem is whenever we are changing anything to do with the build units, we are adding new packages, adding new libraries, modifying the names of executables, you need to redo the cache. There could be commands for it as well. I think it's called ROS or resource ROS. That should basically do the thing. I'm not sure if it's bugged or not, but I'm just usually removing the file and letting it generate again. That's like the most hands-on thing. After this, the workspace is automatically sourced. If you have multiple workspaces, what works is you can quite easily switch between them. So if I rem out this workspace and unrem out this workspace, open new terminal, it's gonna actually say Qualcomm workspace changed, and it's resourcing another workspace. So switching between workspaces, it's totally fine. You just change the bash RC, open new terminal, it's done. Then it's recommended to close all the old terminals because they are going to be sourcing wrong stuff.
So therefore, we cannot have two terminals open with one and another workspace.
You can, but not using this tool.
Right.
You would.
The cache is not shared.
No. I haven't followed this use case yet. Right. You can totally modify it, or you can, for this specific use case, I would probably ditch this completely. To go back, if you don't use the ROS workspace variable, you are free to source anything explicitly like the official say. I can edit my file, I would comment this, and I could potentially just do source workspace core install setup bash, and it will not break anything. Okay, it breaks.
The
shell, yeah, thanks. Worked, but you could see that now it takes time, and there are situations where it takes like 3 seconds, and I haven't had time to investigate why. Yeah, so the pre-sourcing mechanism, I just like it. It solves my problem, but it wasn't developed in like very deep thought, so it might have bugs and edge cases. What I really like right now is the protection against building wrong workspaces. So if I now go into another workspace called build, it's gonna tell me you cannot compile, you are compiling a different workspace than you are sourcing, blah, 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 blah. So this will protect you from
chaining them in a wrong way, which is always painful. So that's
actually, if you do this, then you link it. If you do it intentionally, you really do the linking.
Yeah. But I didn't actually need to do it yet. I'm using one workspace per project, and I haven't touched this problem yet. But it should somehow work. Don't know. Let me know when you research this, please. So that's Colcon. That's building. That's sourcing. I think I've not forgotten anything. Let me check the notes. So Colcon, blah 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 blah. Yeah. So after this, you should be able to compile your stuff, and they should be actually executable. So let me know if you find any problems in there. So now I want to dive into the actual changes in the native C++ API that you should know about. I'm not gonna touch because it hasn't changed that much. It's very similar, I would say. Like hot patching and stuff in Python feels the same in ROS1 and in ROS2. B, Python is very slow. It's much slower in ROS2 than it was in ROS1. Just a simple node with one subscriber and one publisher can eat up to like 20% of a CPU core doing nothing. It's very painful. And I don't think Python should be the way to go. Maybe in special cases, I don't know, wrapping around some machine learning models, that's probably all right. But doing anything serious in Python is painful.
Do you see some relation between the performance or the CPU cost and the communication?
I haven't investigated. Just the bare CPU usage hit is there even with super simple packages, but I didn't want to even investigate this. I have my own problems with C++, and that's enough for me. But we have a quite good Python examples. So like it's totally doable. You can run Python, but just beware about it. It's not for free. I use Python for super small scripts for calling a service, for example. Calling a service, by the way, in ROS1 was quite easily doable in terminal. Right now it's painful, so I'm just writing Python scripts to do it. So I'm using Python, but in a very small portion of my work. So I'm gonna dive into how the C++ API changed and what you should do, what you should know. First important thing I want to talk about is the package structure. The package structure hasn't changed that much from ROS1. We still have package XML, which is basically the same file that used to be in ROS1, even with some reductions in some special cases. We still have CMake lists for C++, which looks similar. There are differences, but you basically don't need to know about the differences if you copy the structure from a package which already works. That's my sort of go-to mechanism. Always having a good example and then stealing from the example. And the examples are already ready and they are there. We have plenty of these. So anything wrong? No, good. So basically the package structure is the same folders, source, launch, config. Maybe something changed in the Python sense. It's a little bit different. But again, we have boilerplate code which you can just copy and paste and modify. So no big deal. What executable? There are still two ways how to write your ROS nodes. There is the way number one, which is writing an actual binary executable, which has its own main, which spin ups some sort of an executor or spinner in ROS1, and that spins the ROS inside node, and then you have your own code with the subscribers, publishers. This was possible in ROS1. It is still possible in ROS2, but I would say it's heavily not recommended to do it. In ROS2, the intended way how to run your programs is as nodelets. In ROS1, we used to have nodelets. In ROS2, these are called components. The mechanism is very similar, just the names differ. So what used to be a nodelet is now a component. What used to be nodelet manager is now a component container. The idea is that you can, or the user actually, not you as a developer, but the user who wants to run the stuff can decide if he wants to run everything separately in their own runtime processes, or if he wants to run multiple nodes under one runtime such that the memory is shared and you have the potential for like speeding up the communication, because when you have shared memory, you can just exchange shared pointers instead of serializing and deserializing the messages, which can significantly improve the performance of image and point cloud transportation. We have been nodeletting everything in ROS1, and we are totally doing it in ROS2 as well. It's quite the same thing. So basically, if you have lived under the rock in the last 5 years, every node that we have is actually a shared library which implements some interface for a class that behaves like a node. But there is no main, there is no actual explicit spinner or an executor that you would define in the main. You just implement the functions of the library. In ROS1, this library had an interface which gave you the option or forced you to implement some initialization method called onInit. You basically wasn't allowed to touch the constructor, if I'm not mistaken. In ROS2, this has been streamlined quite nicely, where you have the ability to modify the constructor. You are supposed to do the stuff in the constructor, and there is no specific method that you are supposed to implement. It's quite elegant, I would say. So if you open any source code of any sort of a node, so I'm just gonna open start node, you are gonna typically find a class that is, in this case, automatic start, that inherits from MRS node. And we are getting into the territory of our own wrappers, but if this wasn't MRS lib, it would be RTL CPP, which is ROS client library C++ node. And then we would do stuff in our own class. So that's how our nodes typically look like. From time to time, you can still find nodes which look the old way with the main and the spinners. You are going to find these in the tests, which needs to be an actual binaries. But I would totally say don't write the old school programs with main, because they don't give you the ability to connect them with others under one umbrella. And there are even some mechanisms that are explicitly different between these components and an actual executables. Like the way how they load ROS parameters is different. For reasons I don't understand, but it's different. So just basically to have everything on the same level, please use components or program components. So that's the first thing that has sort of changed. ROS2 even incentivizes this approach. And this is the first place where you are probably going to find the MRS libs wrappers doing stuff. The first wrapper that we have, I'm not sure if the original author is Matouš or David Tomáš, maybe it's David Matouš, I'm not sure. It's a wrapper around the actual class that we are supposed to extend. That is the actual node. We are modifying this class in a way that gives us the ability to actually do productive stuff in the constructor. If you do it the official way, you are going to find dead ends that are related to not being able to get a pointer to the actual class in the constructor. And sometimes you need a pointer to this class in the constructor to initialize other stuff that need a pointer to your node, which cannot happen simple. If you do it our way, you are totally free of problems, I would say. What's different is that in ROS2, there are much less global C++ stuff just accessible from anywhere. Stuff like
print like ROS info that you could just, this was a macro that you could just call anywhere in your code under one condition, that is the ROS is actually sort of linked into your binary. And you could basically call ROS info in a code that was pure C++, just being used in other ROS code. This is not anymore possible, besides others, because all the stuff that you do with ROS in your C++ typically needs an access to a node pointer. So pointer to the actual class that is the ROS component. I call it just a node pointer. It's of a type of a head pointer to RCLCTP node. You need this to do basically anything. You want to print, node pointer. You want to subscribe, node pointer. Publish, node pointer. You name it, node pointer. So what we do is typically as a member variable, I have a node pointer which I initialize or like set in the constructor for the class using this node pointer method. And from then, anytime I need to do anything with ROS, I access the node pointer. So that's the first difference from ROS1. Which is going to be the most painful probably in the refactoring sense, because all the ROS prints that you used to have suddenly have a different arguments. They look differently. And there might be even a code which was not sort of ROS imbued. There were just the prints, and suddenly you cannot use them because you don't have the pointer. So in some of the libraries that we have, I needed to decide if we are going to have them as a ROS library and be able to do ROS info and ROS error. And for that, you need to somehow pass the node pointer to the actual instance of the library. Or if I'm going to cut out the ROS completely and have it as a native C++ library, but then if it prints, it's going to be std out. So I think most of the time we have decided to actually ROS-citize these libraries. So even our LKF filter, which was, I think, pure C++ before, now accepts node pointer during the initialization such that it can print. So that's the first important difference. Another difference, and I think this is quite a big difference, is how we work with time. Time before was somehow globally available in the actual node. So you could call, I've already forgot how we used to do it in ROS1. ROS time now. And that was a macro, some sort of, yeah, you could somehow work with time, somehow anywhere quite easily. Now, to get the current time, you need to basically ask the node pointer to give you a clock pointer, and there is a clock object which takes care of anything time related. And you can then ask the clock object to give you the current time. Or if you want to do a throttled print, you have to ask the node pointer to actually do the print, and you have to give it a clock pointer such that it knows the time and it can throttle the print. So we are getting into the common problem, or sort of problem. Yeah, it's not a problem, but everything to do with ROS2 is more sort of verbose, more complex. There's more stuff you need to do. So yeah, so just the normal throttled info print, which used to be ROS info throttle. You gave it the seconds and a string. Now you need to pass it a logger object from the node pointer. You need to pass it the clock object, and then you can give it the microseconds of throttling time and the actual string. So everything is a little bit more verbose and more complex. And since we are talking about time, one of the most common problems you are going to face is related to comparison of times. In my own code, it's everywhere. I'm checking if a second has passed since the last time I've got a message, or I'm checking something against something. The problem is, right now, the times, the RCLCTP time object, which you can store, and you can then check two objects against each other and check the difference. These objects store the type of time.
We have different types of time. We have the actual time, sort of the computer time, I mean. We have a simulation time, and we have a ROS time. I think we have totally 3 times, the time types. And if you do it wrong, if you check 2 different times against each other and they are not of the same type, you are gonna get quite unverbose runtime error. Something like, cannot compare 2 different time sources, bye-bye. So typically, I'm speaking about this. So time from arming, in this case, is clock now minus armed time dot seconds. This operation is sort of unsecure, because if this armed time is a different time type than this, you have a runtime error. And you can easily get a different time type just by not initializing this variable properly. And for doing it properly, you need to know what time type you are supposed to know. So for the actual initialization, you have to somehow get the time type, which you can ask the clock object to give you the time type, but not always you have the clock object at hand when you are initializing the variable. And this can give you problems, and you are probably going to facing these problems often. So know about this, please, that anytime you are storing RCL CPP time for later use, if you are initializing it, you should always initialize it with whatever 00, whatever you want, and then give it the right clock type, which you can ask from a clock object, which you can ask from the node object, a node pointer. Or anytime you're doing the comparison, you should probably manually check if the types are equal and do a thing, and if not, do something then crashing, which is what ROS does for you. So beware, this is a common issue. It will typically show in the real world before it shows in the simulations. And it's a pain. And since we are speaking about time, let me speak about sim time. In ROS1, we used to have the distinction between the actual time, the wall time, and the sim time. And whenever we simulated, we exported or set a parameter in the centralized ROS param server. This parameter was in use sim time equals true. And this would tell all the nodes, that they are supposed to subscribe to /clock, which then defines the speed of time, because the clock is typically published by the simulators. And it was sort of easy. You basically exported this param once, and every node would listen to it. Since ROS2, in ROS2, the nodes are distributed. Each node keeps its own track of time. There is no centralized authority which would tell all the nodes you are supposed to listen to a simulated time or not. So difference number 1, we need to tell each node that it's supposed to subscribe to simulated time if you want to simulate. And then it's the node's sort of work to actually subscribe to /clock and run on the correct time. So if you don't account for this in your launch files, your node might actually run on a wall time if you simulate, and this could cause problems because the times might run at different rates. So you should know about this. In all the example launch files that we have, we are going to typically find an argument which is called use sim time, the same as in ROS1, but this is sort of our choice, which is by default false. And this argument is then passed as a ROS param into the node, which tells the node that it's supposed to subscribe the simulated time. Yeah.
But do you have to handle it by yourself, or is there some command in C++ for using this sim time specifically?
Yeah, if you do this in C++, you are automatically getting a clock object which knows only about the simulated time. And then if you want to use wall time, you have to explicitly create timers that run in wall time, but you have to do it on your own. But the node by default then lives in the simulated time.
So if I just set it up in the launch file, that's it?
Yeah, that's enough, but you have to do it, yeah. So what we have
in the system is this little piece in each launch file, which by default runs sim times to false. And if the environment variable capital use sim time is set to true, it then automatically turns the sim time to true. So in our simulated sessions, you are going to find export use sim time to true, which is going to boil down into all the nodes and set this to true. But it needs to be done in the launch file explicitly, otherwise it's not going to happen. Yeah. You should know about this. Yeah. So that's time. So to repeat what just happened, we have the nodelet with the class that extends the RCL CPP node. In our case, it extends the MRS lib node, which does some stuff under the hood to make it life easier for you. And in the constructor, we are just setting up the node pointer and the clock pointer that you need to actually do stuff in ROS. Yeah, clock object time, think time, comparing times. Awesome. Then we have the new stuff that did not have a parallel in ROS1. It might be a good thing, it might be a bad thing. The problem typically is that the default behavior is not very nice in ROS2. So you cannot just avoid these, you have to know about them to do the stuff right. The first stuff I'm talking about are the callback groups, so-called, which is, I think, a good way that gives the programmer control over what callbacks can run in parallel with other callbacks. In ROS1, this fine-grained control was not possible. You basically registered subscribers, service servers, timers, and you could only specify the number of threads you gave to your spinner, and that was it. And the callbacks were somehow called in whatever fashion. In ROS2, you have the option to explicitly group callbacks from timers, service client, service servers, subscribers, and maybe others. You can group them into groups, and you can specify how these groups are supposed to work. You have two types of groups. You have mutually exclusive group, which guarantees that callbacks within these groups are not gonna run in parallel. And then you have free entrant group, which gives the callbacks the freedom to run in parallel, even to the extent of having a single subscriber callback being executed twice in parallel. If it just takes too long and data come in too fast, it can happen that it will actually run 2 times in parallel. So you have the option to define the groups, to assign the callbacks to the groups, and it's up to you how you sort of divide the structure of your program. If you really know 2 callbacks cannot be called across each other, you give them one mutually exclusive group, and then you are good to go, and you don't have to deal with memory safety that much. It might be a good thing. The control is totally there. The problems are with the safety sometimes, and the problems are with the default. So if you don't know about this mechanism at all, and you just use ROS2 as you used ROS1, every callback that is created, or sort of every node that creates callbacks, or every object that creates callbacks, will assign them into the same mutually exclusive callback group of the node. So the node itself has its own one golden callback group, which is mutually exclusive, and all the callbacks are assigned to this group. And what is a typical problem with ROS2 beginners, myself included, is that you are gonna create a subscriber, and in the callback of the subscriber, we are gonna call a service. Data came in, I need to do a stuff, I'm calling a service, and your program does a halt. It halts because within the callback of the subscriber, you call a service which needs to present you with a response through a callback mechanism, but this response is not going to be presented because we are still in a callback, and there is a deadlock happening because you run everything in a mutually exclusive callback group. And this is the default behavior. Many people have sort of got stuck in this. The solutions are simple.
You either diligently, explicitly define the callback groups yourself, and whenever you create a subscriber, you pass it to right callback group. Whenever you create a service server or service client, you pass it another callback group, and then you are out of the problem. But the defaults are not nice. So it's good to know about this if you work with native ROS. I think we have solved this within our wrappers in such a way that, for example, if you define a service client and you don't specify a callback group, the service client handler, the wrapper that we have, automatically creates a fresh callback group just for the service client. And this is happening under the hood, and you don't know about this. And this makes sure that whatever you do, the service client will always give you an answer. We have done this, I think, in the right way to make it seamless. But we are not getting into your way, and you can still specify everything explicitly. But if you don't use our wrappers, you could fall into traps like this, which are kind of hard to debug and understand if you don't know about this mechanism at all. So in some of my notes, you are going to find an explicit definition of the callback groups. I typically like to group together subscriber callbacks, service client callbacks, just to have it somehow clean. I haven't put much thought into optimizing this. There was no time for this, but you should definitely know about callback groups. Again, if you don't want to learn, just use our wrappers, and the default shouldn't cause you any big troubles. The defaults in ROS2 will cause you troubles, totally. So that's the first mechanism, which is super new. And the second mechanism that is super new is so-called quality of service. In ROS1, the communication between the nodes was happening using a proprietary TCP/IP/UDP-based layer that was part of ROS, and there wasn't much of a wiggle room of how to set it. You basically could subscribe in an unreliable or reliable way, and that was all. The reliable would use still, I think it was UDP, but with some confirmations. The unreliable was just UDP without confirmations, and that was all you could do. In ROS2, this is 10,000 times more complex, and it is connected to the fact that ROS2 doesn't rely on its own communication layer, but it implements sort of an abstract interface between a distributed transport system, and you can plug in many implementations of distributed transport systems that can do the work. And there is even a joke on the manuals or on the tutorials that you could even plug in a mail system as a transport system for ROS2. You could sort of subscribe to a topic over a mail. It's a joke. It's a joke that it can basically do many things. I'm not saying you should do it. And many of these transport systems can give you some sort of quality of service guarantees and settings. So sometimes I'm not expert. I don't understand this fully. I have just a vague understanding. But an example that I think I understand is sometimes you are streaming data from a sensor, like an IMU, on 100 hertz, 1000 hertz. And the system that processes the data typically cares about the latest sample. And if there is some clock in the network and suddenly you have a outage, I don't know, 100 millisecond outage, and then the data somehow comes in all at once, in the IMU case, you probably only care about the latest sample anyway. The ones that came in later are discarded. So one way how you can treat quality of service is basically, I want always the latest data. I don't care about the one that comes late. Always give me the latest one. And sometimes you care about all the data. Even though they come late, you still want to process every bit of data. I don't know, this would be some detections of a system that needs is important, and you really want to catch all the ones that happen positively. You can't just skip them and say, okay, I care about the latest thing. So sometimes you want the system to be configured such that it always presents you with all the data, Therefore, you need some sort of buffer. Then you have options of how long the buffer is and stuff like that. Configuring this is on both ends. You can configure the quality of service settings for a publisher. You can configure quality of settings of a subscriber. There is a whole page on the documentation, I mean the ROS documentation, and it's kind of complex. There are different aspects of the quality of service, some timeliness, liveliness, whateverness, and some go totally against each other. Therefore, there are some profiles that can be created out of all of these aspects. And typically, we have two profiles that we use. We have a system default profile. Most of the time, that's OK. And sometimes you have sensor profile, I think. That's for the data that's basically the latest one is the important one. You don't care about all the images that didn't get through. What's important is anytime two incompatible quality of service settings meet, the one that is dominant sort of tries to downgrade the non-dominant one. So if a reliable connection meets unreliable connection, in one sense, I don't know this from the top of my head, but in one sense, I'm gonna try to think this out. So if a reliable publisher meets unreliable subscriber, unreliable literally means like, yeah, I can connect to even sensors which might not send me all the data. So if reliable publisher means unreliable subscriber, the reliable publisher can downgrade itself to the unreliable level and they can connect happily. But if you have unreliable publisher, that means reliable subscriber, they are not gonna connect because the quality of service would not be guaranteed. So it might happen if you do it wrong that you have a node which happily runs but doesn't get any data. It's because these two didn't talk to each other very well, and you might not even get the info from the prints. The node just runs, and it's looking like it's not getting any data. I don't have to go deep into some ROS topic info, verbose, and see how the reliability meets, and you are going to find that, oh, I cannot actually subscribe to this. I have too high standard for the data quality. So beware, this can bite you in the beep. And I usually don't deal with it. I just set up my quality of service to the system default, whatever. I don't even know if this node has it yet. So for example, I'm creating a subscriber, and as one of the arguments, I'm passing RCL-CPP system default quos. This is actually a profile which sets some aspects of the quality of service in a way that is like okay for most use cases. So you should know about this. I probably cannot tell you more because I've only touched this on the surface to the level that my nodes run. But the problems that you might face is the data is not getting into my subscriber. The problem number two might be a lot of prints coming from the underlayer of the communication, which says it cannot migrate the data somehow. This happens, for example, with the cyclone layer. The cyclone, which I'm going to get to later, will tell you that something is wrong. The other layers will just print nothing. They will say, I'm happy, and the data is not flowing because the quality of service is wrong. So you should know about this. I think that in the wrappers that we have again set this to the right default. So if you do the stuff using our wrappers in a blind way, if you migrate ROS1 to ROS2 and you don't explicitly insert this argument, it should happen just right, I think. If it doesn't happen just right, you are going to be forced to learn what profile to set correctly. So beware. So these are quality of service settings. I think, again, this is an upgrade, totally, from ROS1. You have fine-grained control. The problem is with the defaults, which are not totally right, I think, all the time. And the problem is with the education. Like, I have been to the page many times, ROS2 QoS, but it's so abstract, and there is like no code that just knowing what to do.
Just stable.
Yeah, like knowing what to actually do is always hard, because this is like a page that is written, like it's about the concept. It's not about what you should do in the C++ to actually make it work. So I hate this thing. So I only read about this briefly. Okay, and we are getting close to the communication layers, so I'm gonna probably stick to this topic as well. How much time do we have? Okay. Let's give it 15 minutes and then let's do a break. So the communication layers in ROS2 are actually not ROS2. They are third-party libraries that someone developed to facilitate communication, sort of subscribe, publish communication. And now somebody implemented an adapter for that communication layer into ROS2. What's interesting is that it's all built about decentralization. So in ROS1, we had the core, the ROS core, or the master, the ROS master. Somebody maybe invents another name. And you had to run this ROS core first, such that then you can run the nodes and they can talk to each other through the ROS core. The ROS core was like the mediator of who is where, who listens on what port. And without the core, nobody would connect to nobody else. This was probably a problem for many people, so they decided that ROS2 should be totally decentralized by design. So many of these communication layers in ROS2 are actually decentralized. So whenever you run a ROS node, it does not connect to a core. It uses something called the gossip protocol to scout the network. It sort of broadcasts into all the networks that it can see that I'm here and I'm publishing this and I'm calling these services and who can answer me. And if there are other nodes running, they can answer, I'm here, I'm going to subscribe to your topic and I'm offering these topics. And this is good because this is good in a way where you don't have to set up any infrastructure, you don't have to run the core, you can even have the communication between different computers and robots seamlessly running without making sort of configuration. So that's problem number one, or thing number one. It's totally decentralized, comes with benefits, but with huge downsides. The first communication layer that was sort of used predominantly in ROS2 is called fast RTPS, which is built using a library called fastDDS, if I'm not mistaken. Vojta might correct me. And this is still in ROS2 Jazzy, the default communication layer in ROS2. So if you just installed ROS2 and you don't know nothing about the so-called RMB, RMW, ROS middleware, that's the communication part. If you don't know anything, you're probably gonna run fast RTPS. And you don't even know about this. So whenever you do ROS launch, no core is started, the node just lives on its own, and through this, it will scout the network and it will find another node such that it can connect. It's fine for 98% of users. Sadly, we are the top 2% which have a problem with this. There are light problems like the speed of discovery. If you call ROS topic list or ROS2 topic list and you are running this, the output is non-deterministic, meaning you might get a different output now and in 2 seconds, because the ROS topic list actually does a discovery, and sometimes some nodes might not answer because of some sort of a delays or communication problems. If you run a node and the node immediately after it's come to life wants to publish and call services, the data might not get to the right endpoint because it takes few seconds for the node to get the actual list of topics. Basically, each node needs to do its own ROS topic list, which is dynamic. It takes time. So beware. Problem number 2 is related to something called ROS domain, which is here in the
in the official docs. I hate the documentation. You read about this concept called ROS domain, and it doesn't tell you how to actually set the ROS domain. Like, how? Is it a config file? Is it an environment variable? I don't know. It's an environment variable. By default, everyone runs on a ROS domain number 0. That's basically a subdomain in which all the topics are shared with the others running with the same domain. And what can happen typically if you don't set this domain, if you run fast RTPS and you sit here in the campus, you do ROS topic list and you see topics that are not yours. Because someone else in another room in whatever lab runs ROS domain 0 with fast RTPS and the topics somehow get to you.
Is it the port number actually, or is it?
I don't know. I don't know. It's my gig. And I didn't need to know, but I'm going to tell you how we circumvent this. So beware, it often happened that I was simulating, and my simulation was doing weird stuff because of clock, because of the absolute topic /clock, which somebody else was publishing from its own simulator in another floor, sort of migrated to my simulator, and it broke my simulator. Of course, it was my responsibility to set the ROS domain to something else than 0, but how do you set it? There is no manual to do this. So beware, the system is opt-out by default. So unless you actually specify that you want something else, it shows you topics of everyone else in the network. And it's going to be super frustrating. So that's fast RTPS. Obviously, there are ways how to configure this. You can run a sort of, they call it a discovery server, which then makes sure the nodes can actually discover stuff fast. So basically, this gets back to the ROS core. And there are ways how to isolate yourself from the rest of the people. So I wouldn't be against this. This is very powerful. However, for us, right now, there is a runtime problem. If you run this on a drone, this drone can actually pick up quite heavily, meaning that whenever the drone flies using this, and you are, for example, sitting with your laptop on the network and you call service to the node, to the drone, something like land, the ROS system in the node, which receives the call, can freeze for like a half a second. It happened to me repeatedly. It was super frustrating. It's basically on a level of dangerous. So right now, I'm forbidding all of you from running this. If someone wants to check if it's still a problem, feel free. I haven't checked for half a year, but it was super frustrating. Otherwise, it's okay. If you configure it properly, it can work quite nicely. We have still a few minutes before the break. So this is the fast RTPS layer, the default layer in ROS2 Jazzy, which we don't like currently. Maybe in the future. There are alternatives. Most notably, the second alternative is called Cyclone, which right now I have nothing wrong to say about. I think it's good enough. And there are some metrics which we can use to say if it's good enough or not. We are in a state or in a position where we care about fast delivery of data, like 100 Hertz control signal, and we also care about like large data, point clouds, images. This used to struggle with large data. I think it does not anymore. This used to struggle with fast data. I think it's not the case anymore, but I'm not sure. I have actually looked with this for something like 15 minutes in total, so I don't have any significant findings. It worked, but it also might have some problems which show up once in 20, and I just didn't know. So I didn't like register this. So Cyclone is possibly useful. It also works like the fast RTPS. It's a distributed thing. You don't have to set up a thing to actually see the topics on your laptop from drone. I just don't have enough data to tell you you can fly with this. It might totally happen that you are going to take off with a swarm and 2 drones will just stop flying because of a problem. I don't know.
if you are free as a beta testers, you can try this and just tell me if it works for you. Like the system will fly. I just don't know if it's good enough. Then there is a third system, which is called Vino. And this is sort of a, yeah, this is a good thing. This is a mechanism which I like a lot because A, it's opt-in. You have to actually configure it to do crazy stuff like the dynamic discovery, like the distributed mechanism, but you have to want it. But by design, it's a centralized thing where you run basically a core. They are calling this a router, and the nodes communicate with the core, and then they actually find out how to communicate with each other using the core. So that's the first good thing. Behave like ROS1, and you have control, and you have so much control. There is a config file for it. It has like 1,000 lines of stuff, and you can do crazy stuff. On a scale of centralized to decentralized, you can be anywhere. You can be totally centralized, where you explicitly tell the nodes to connect just to the core and to no one else. You can be somewhere in the middle, where there is going to be a core, and the nodes will also try to scout for other nodes, so they can discover nodes from your laptop, even though you don't tell them specifically that there is a laptop. And you can go to totally decentralized, where you have no core, and they scout for each other, and you are basically here. And the default is in a centralized fashion, which I really like. There are also other neat aspects of Xenoch. For example, if you have two robots which live in their own networks behind router, behind NAT, and they don't see each other, you can run this thing on some public network. You can expose it. You can tell the drones, the robots to connect to the public core, and that core could mediate a communication in a way where all the data, not just the ports and who is where, but all the actual data, the point clouds, the images can flow through the core, through the public network, and the robots could actually see the topics even though they don't see each other on the same network, which is super beautiful. Configurable in all the possible ways you could imagine, and it works with fast data, and it works with large data. It has a specific configuration where you can say how the data is supposed to be chunked, what are the waiting timeouts for the packets to arrive to the other side, such that you can compose them back into one large message. So it can be totally configured to do whatever you want. And we are currently flying with Xenoch, and you should be, because it works. And I can sort of guarantee that it's gonna work. I cannot guarantee with this or this. When you are simulating, do whatever you want. But on a real drone, please use Xenoch. So let's have a break, and after the break, I'm gonna go under the hood, how to set this up, and what you should know about the actual runtime.
Xenoch also does
Yeah, that's still, yeah, that works.